Let's see an example for dependent events. A box contains 4 red and 2 yellow tickets. 2 tickets are randomly selected from the box one by one without replacement. Find the probability that both are red, or the first is red and the second is yellow. So when we see this expression without replacement, we may think that here we're going to have dependent events. Dependent events. Okay? And to organize the information here, I'm going to make a tree diagram. So when you take the first ticket, this is, I think it's better if I write that below. This is for the first ticket. We can get a red one or a yellow one. Now, for the second ticket, if the first one was red, we have two options. We have another red or we have a yellow one. Okay? If the first one was yellow, the second one can be red or can be yellow. Okay? Here the sample space is that we have a red red, red yellow, yellow red, or yellow yellow. Okay? So now we are going to define the probabilities for each possibility. So let me start with the first one. And it's the case that we have, or we take the first one as a red one. If we see there are 6 tickets at the beginning, okay, we take one red, and after that we are going to have only 5 tickets. So the probability that the first ticket is red is 4 out of 6. We had 6, 4 of them were red, so that's why we have this probability for the first ticket. Okay? For the second ticket, now we have 5, and 3 of these 5 are red, so that means that the probability that the second ticket is red is 3 out of 5, and the probability that the second ticket, given that the first one was red, is 2 out of 5. 2 out of 5. Let me... yeah. And now, what is happening when the first ticket is yellow? Okay, so at the beginning we have 6 tickets, and 2 out of 6 are yellow, so the probability that the first one is yellow is 2 out of 6. And then we don't have this yellow. Now we have 5 tickets, and then for the second ticket we observe that there are 4 out of 5 for the red option, and we have only 1 for the yellow, so this is gonna be 1 out of 5. Okay, to check if we are writing the probabilities, we need to see if, for example, here these two, the addition of these two probabilities is equal to 1, so this is correct. Then for this event, we see that the addition of these two is equal to 1, so this is correct. And when we check this option, or this part, the addition of these two is equal to 1, so this is also correct. So now we have the information to calculate the probabilities, and I'm going to start finding the probability that both are red. The probability that the first one is red is 4 out of 6, and the probability that the second one is 3 out of 5. This is the moment when you see that we have dependent events. This probability was affected by the previous event, and that is the reason that the probability is different. Okay, so now we can calculate that the probability, let me put them here, the probability that the first one is red and the second one is red is 4 out of 6 times 3 out of 5, and this is 12 out of 30, and we can simplify this as 4 out of 10. This is the probability that both are red. And now let's find the probability that the first is red and the second is yellow. The first one is red and the second is yellow. So we have the probability that red, yellow, and that is going to be the product of this times this. 4 out of 6 times 2 out of 5. This is 8 out of 30, and that is 4 out of 15. Okay, so here we have the probability that the first one was red and the second is yellow. And that's all for this example.